unable to attend our open house today, we put together this informative video for you so you can see all of the exciting technology that we're introducing. Let's go inside.
Hi, I'm Gabrielle with Creaform, and this is the new GoScan 3D Spark. So we're going to see it in action. As you can see, it's all in one line. We have 3 cameras instead of the 2 that we had before. The projection, the color, and then now we also have lights on the outside and right here so you can see your distance. And you have not only buttons on the left, but also on the right that mimic the same thing. Rubber stops as before, and these cables can be switched out for the same cables as your Max Shot or your HandyScan Black. So let's go ahead and get started. So I'm going to just find a little spot where I was already scanning here. And it's going to recognize it. So what you're seeing here on the screen is the laser lines. And now instead of the distance meter being on your left side, you have it on your part while you're scanning. So if I get too close, my laser lines turn red. And if I get too far, they turn blue. So this is just helping me for better accuracy to try to maintain the surface that I'm scanning in the green zone. Alright, let's get the bottom of him. Just doing a quick scan to get the general idea that it can be done really quickly. And right now we're scanning at a 1 millimeter resolution. That means that the sizes of every triangle that creates the surface of this snowman is 1 millimeter in size. So let's go ahead and stop that, and it's already done. And there we go. It's really, really good color and good geometry for just the quick scan that we did. Of course, we can spend a little bit more time to fill in everything else, but that is what we have.
And here we have our Sinter 1 sintering oven for post-processing 3D printed parts of our Markforged Metal X printer. This side of the room we have our Big Rep Studio, which is a large format 3D printing. Over here on the table we have several examples of parts that were printed on the Big Rep. So the Big Rep will use plastic material, FDM technology, PLA, Pro HT, which is an ABS-like material, and we have a 1 meter by half meter by half meter build size, so we can make fairly large parts at very reasonable pricing. Here on this side of the room, we have our Markforged Metal X 3D printer, currently printing in stainless steel with other materials on the way. Immediately to my right, we have our desktop series. We have available nylon as well as onyx, which is chopped carbon fiber filled nylon, and we can additionally reinforce those parts with continuous fibers such as carbon, Kevlar, fiberglass. On the far right, we have our X7 composite 3D printer, also available with nylon and onyx and continuous fiber range.
Hi, I'm Kenny Hart with NeoMetrix Technologies. So today we're going to show you the new HandyScan Black. This is the brand new model from Creaform. It's a little bit of a boost from its predecessor, and we now have 11 laser lines versus the 7 the old one had. And what that allows us to do is take up to 1.3 million measurements per second. So we're going to scan this part right here. Now with this model, we've got much higher resolution, and we can actually achieve an accuracy of 9/10 of an inch over the surface of this part. And what they've done as well on the back of the scanner is we've added some more function buttons here. So just on the back of the scanner, I can change my shutter speed for my surface acquisition. I can change the resolution and my physical scan area just by going into the menu right here. So all the functionalities on the back of the scanner now, no more back and forth between the scanner and the laptop. Once we're finished up with the scan, I'm going to go ahead and finish this here. We've, just like the old handy scan, we brought over the single line mode. I'm going to zoom in. So this lets us get into real tight areas, holes, things like that. Once you're done scanning, what's very unique about this scanner is we are a direct to mesh scan now. So there's no more mesh processing time. What you have here in that 1 second is the final mesh that you're ready to export.
Our first actual example is going to be done in Geomagic Design X. So this is our reverse engineering software. What I'm going to do to start is run this auto segment wizard. And what this wizard does is it analyzes the mesh and it breaks up that mesh into a whole bunch of usable regions. So you can see if we hover over these regions here, it'll recognize them as planes, revolves, cylinders, freeform surfaces, things like that. Now they're not physical CAD surfaces, they're just on the mesh, but what we can do is use them to extract our CAD surfaces from them. If you got to do any editing, you can certainly merge a few together like I'm going to do here to make one big revolved surface. It's just going to help me out with the modeling. So we're going to start with the Revolution Wizard. We're going to use it to model the main rim. What we can do with this wizard is select the regions that bound the geometry we're looking to model. So we're going to select all the way around the rim here, every single region. Okay. Along with the revolution axis, we want to make sure we have it constrained to this main axis here. And when we run the wizard, it's going to create a sketch automatically and revolve that sketch around that chosen axis. And you see, just like that, we've got the rim modeled. And what is nice as well with Design X is we do have the ability to go back and edit the sketch and the revolve if we need to tweak things a little later. But next we're gonna model this long main spoke here, and we're gonna do that with another method called the mesh sketch. So mesh sketch is a regular sketch. We're gonna select this plane, and what this plane's gonna do is bisect the mesh and give us a profile which we can trace essentially. So here we've got our profile, we're going to localize it a little bit, and we're going to get this pink reference polyline. Now the bottom, this little cutout is a pocket. That's going to cause us a little bit of a problem, but we'll fix that here in just a minute. We'll start by sketching the top profile, which we can do with our sketch entities here. Now you can see we can snap entities right onto those pink reference polylines, the basically trace lines. We're going to finish up this top profile with a few tangent arcs here. Okay, and then I'm going to square off the bottom just to make sure it's inside of the geometry, the central hub, which will be another modeled feature a little bit later. All right, so let's get that squared up. And now we're going to have to go and sketch the bottom of the spoke. So now I'm going to go back into my sketch setup, and I'm going to revolve that profile just slightly to where we get the bottom surface, good profile sketch of it. Now we can go right back into the sketch and continue on what we were doing. I'm going to grab my my arc tool again, and we're going to fit a few more here to the bottom, a couple of these hard edged lines. So you see we're just snapping onto those segments there. And now we're going to trim them all back up. So let's grab our trim tool, and we're going to make sure all these endpoints connect. Now with a smart dimension, I can go back and edit the angle here, so I can make it an even 150 degrees, more like what the design intent would be. And then we're going to close this profile with a fillet on this area. So you see I can drag the fillet into place, and then again go ahead and change that fillet number to the next round number. All right, now that we've got everything sketched up, we're going to close our boundary here. Exit our sketch and create a standard revolve. But we're not going to revolve it all the way. We're just going to do it part way, just so it bounds, just so it extends outside of the boundaries of the spoke here. All right, that looks about right. Okay, and now we're going to actually create some surfaces to trim that back. So I've used the mesh sketch function to create all these sections off camera, but we're going to use them to create a surface loft on each side. So we'll go ahead and loft both of those down, and then we're going to use the surface extend to make sure that the edges of those extend past the CAD file itself, and then we can use that for trimming. So here we got one side. We'll go ahead and do the other. Okay. And then we're going to use both of those again to cut the center portion out of this revolve, and that'll make up the body of our spoke. We'll go ahead and keep that center section there, and there's our spoke. It looks pretty nice. Everything's overlaid really nice with the scan. Now we just need to add a few fillets. So we'll do this top fillet here, and that should just about do it. So that looks pretty nice. We'll go ahead and move on to the next feature. So now what we have left to do is create our second two spokes. I'm suspecting these are mirror images of each other, so we'll find that out here once we create one and I mirror it over to see if it matches. We're going to do this one a little bit differently. Instead of creating lofts, I'm going to use DesignX's mesh fit surface feature. So mesh fit surface is basically an automatically extracted single patch surface that we can grab from these regions that we created earlier. We'll apply a surface to each of those regions and then trim them all back, as you can see we're doing here. So I'm going to make sure they all trim up nicely together, and that's going to create the boundary, or basically the surfaces, all of our surfaces of our spoke. Now, if we take that and mirror it across this plane, we can see that it's extremely close. So for design intent purposes, we'll go ahead and use that as a mirrored part. We'll revolve our hub here and then make a circular pattern with this surface I made for the lug bolt cutout and our three spokes around the center vector of the wheel. There we go. So we've got all of our features ready to go, and we can merge those together with our outer rim, and that'll create one singular piece which will make up the bulk of our CAD modeling. All right, now that we have one single CAD file, we can continue with the last steps of our modeling. To begin, we'll cut out the pattern bolt recess cutouts, I should say. So we'll cut those out in the main body here, and then we'll hide those, and what we're going to do next is use those same cutouts to create a mesh sketch on the inner portion that makes the actual through holes for the bolts. So we'll click on that surface there and go ahead and get our nice cross section. That way we can extract our reference polyline that we can at this point trace with our sketch tools and create those bolt holes. There we are. Now we've got our circles there ready to go. So just like before, we're going to take the circle tool and just click on that circle. You see it's going to apply an automatic circle there. We can make it any dimension we want at this point. So go ahead and make it 11¼ millimeters in radius, and then pattern that just like we did in 3D with the bolt recess surface cutouts and the spokes, but we're doing this in 2D with our sketch. And now we're going to extrude those profiles and make a through cut. All right, so now what we got left to do is create a bunch of fillets. So we're going to create the fillets around the boundary here. We're going to create some more fillets around these spokes. Create more fillets and more fillets. And finally, a few more fillets. That should be the last one right there. So everything looks pretty good. All right, and that's our completed CAD model. So looks like we've got all the features modeled there. The last thing I want to show you is what's called the accuracy analyzer. What's very nice in Geomagic Design X is that we can compare our CAD file to our scan at any time during the modeling process and see how well we've adhered to that design. So that looks pretty close, and that's going to wrap up our reverse engineering example.